So I guess there's no question to be asked. So I'll welcome you to our online lesson, Math Made Easy with PDY, in collaboration with eLearning Ghana. And in today's lesson, we are actually going to look at what we call implicit functions, how to differentiate implicit functions. It is one of the applications of differentiation. Going to implicit functions, someone may ask, what is an implicit function? If you studied the kind of questions we had in our previous lesson, you realize that they always wrote the function as either y equal to an expression. So you may have either y equal to 3x squared plus 4x minus 5. So this is one example of a function. But this function is not an implicit function. This is an explicit function. Why do we say that this is an explicit function? It is a function for which the variable or the function has been expressed specifically with respect to some specific variables. So for instance, you've made y the subject and y has been written in terms of x. So this is a pure explicit function. You may even have a function like y equal to square root of s squared minus 4. This is also a pure explicit function. So why is it an explicit function? Because this function has been written in terms of x. So that is basically what explicit functions are. But when we consider implicit function, it means that it's a kind of function whereby no specific variable has been made the subject. No specific variable has been made the subject. And for that matter, both x and y are being written all together. Both x and y are being written together. So if you have a function like 3xy plus 4x minus 8 equal to 0, this is an example of what we call an implicit function, because no specific variable has been made the subject, or the function has not been written in terms of other functions or other variables, sorry. If you have an example like 3y squared plus x squared equal to 4xy. This is another example of an implicit function, because no specific variable has been made a subject from the given function. My people, are you all clear with the explanation of what explicit functions are and what an implicit functions are?
Yes, sir.
Okay, so again, I said this is an explicit function, and that is an implicit function. So in all cases, they may ask you to differentiate. And when you are asked to differentiate, since most of the examples we've done previously was on explicit function, when you are differentiating explicit function, you realize that you always differentiate with respect to x. You always differentiate with respect to x. That same idea comes to implicit function, but there is more to be done when it comes to implicit function. Whenever you are differentiating an implicit function, please don't be tempted to make any variable the subject before you go ahead to differentiate. You rather make the work more complicated for you. So instead, maintain them as they are and then differentiate accordingly. Remember, when you are differentiating with respect to x, if you are differentiating, let's say, if you are differentiating y equal to 3x squared plus 4x minus 5. when you are differentiating, you differentiate them term by term. So let's say you are differentiating y with respect to x, it becomes dy dx, because you differentiate with respect to x, so it becomes dy dx equal to, now over here when you differentiate 3x squared, it is going to be 2 multiplying 3, that is going to give us 6x, but it goes with, because you are different to x, it becomes dx over dx. But dx over dx, what number does it give us, please? Or what does it give us? And that's obtaining. When you differentiate,
1.
It gives you 1. So it's, in other words, it makes this whole expression 1, and it becomes not necessary for you to write dx over there. Then again, the next variable, the next term is 4x. So differentiating x with respect to x, it becomes 4, and I hope you know why we are getting 4. But it becomes dx over dx again. So it also gives you another expression of what? 1. This has x over there. It gives you plus, okay, minus 0. So minus 0 dx, for which dx over dx will still give you what? 1. So finally, you realize that the answer we write for this question will be dy dx will be equal to 6x, because dx is giving us 1. We don't bring the 1. Then plus 4, because dx is also giving us what? 1. So the final answer for differentiating y equal to 3x squared plus 4x minus 5 is 6x plus 4. So as I was saying, when you are differentiating explicit functions, because you always differentiate with respect to x, then it means that any other variable that comes on board going with respect to x should be introduced. But if you are differentiating the same variable with respect to x, then you end up getting 1. So those dx over dx will cancel out, and then you don't need to represent it again. So that same idea will be applied when it comes to implicit function. So let me take one example of an implicit function. Let's say this one. I'm going to consider the first example here before we go into detail. This is just an introductory aspect. I'll go back to review whatever I've said for better understanding. Okay, so we've been given a question like 3xy plus 4x minus 8 all equal to 0. We've been asked to differentiate. And as I said, when you are given an implicit function to differentiate, you are not supposed to make any specific variable the subject before you differentiate, but you maintain them as they are and then go ahead and differentiate. But always bear in mind that you are differentiating with respect to what? X. So in this case, per our question here, we don't need to make y the subject, but we have to go ahead and differentiate. Now, if you look at the question carefully, you realize that all variable has been written all together. So if you are differentiating term by term, you should know the rules to apply. Now, based on our question we have here, having 3xy. Now, the x multiplying y should give you an information as to how to differentiate 3xy. Now, if you have two functions multiplying, which rule do you think is appropriate to use to differentiate such a function? Yes, which rule do you think is the product rule? Wonderful. That is good. So in this case, this is how you go ahead differentiating such a function. Now, you maintain the first function because you are using product rule here. So if the first function is 3x, then it means you are going to have 3x multiplying the derivative of y. Remember, y is a different variable. So differentiating y, it should go with dy dx because you are differentiating with respect to what? X. So you are going to have, when you differentiate y has a power of 1. So you are going to multiply the power by the coefficient and then subtract 1 from the power. So you end up getting the derivative of y will give you 1 dy dx, because remember you differentiated with respect to what? X. Then we continue with our product rule plus, then we maintain the second function. What do you think will be the second function, please?
Y.
Not just y. Look at it carefully. What do you think will be the second function?
3y.
It will be 3y, because the first function was 3x. Therefore, the second function will be 3y. Then we differentiate the x which is left in that function. Yes. So when you differentiate x which is left over there, what will you obtain? What will
1.
you?
1.
Okay, so you obtain 1 dx, which is the same as 1. So we are done differentiating the 3xy. Then we go ahead to further differentiate the other terms. When you differentiate 4x, what do you obtain?
4.
You get 4. Thank you. Then we differentiate 8, you end up getting 0. And all this must be equal to 0. So you end up getting this. Going further, we are going to have 3x dy dx plus 3y plus 4 equal to 0. Now, at this moment, since we've been able to differentiate perfectly, now we need to make something the subject, which is the dy dx, because that is what would actually give the explanation that we've differentiated the whole function. Even though we've done it, but to make it perfect, then we have to make dy dx the subject. Making dy dx the subject, then we need to transpose our 3y plus 4 to the other side of the equation, and then we divide through by 3x. So in doing so, dy dx will be equal to minus 3y minus 4 all divided by 3x. Please, does it make sense? What I've written here is just change of subject at this moment. Does it make sense to you?
Yes, sir.
All right. So that is how you go ahead to differentiate implicit functions. Always make sure you differentiate term by term, use the rules where necessary, and then make dy dx the subject at the end of the day. And you have then find yourself successfully differentiating the function. Please, are we all clear with what I've said concerning differentiation of implicit function?
Yes, sir.
Okay. So as I said,
Yes.
I've said it, I'm going to review it for you to understand and give you some small notes on that. So when we consider implicit function, it's a function in which no variable has been or can be expressed directly in terms of other variables. And that is what we term as implicit function. Now, when you are differentiating implicit functions, now it is not necessary for you to express one variable as explicitly in terms of other variables before differentiating. It's not necessary. You don't need to do that. Now you use the product rules or chain rules or both where necessary. Yes, that's what you need to consider. And then examples of implicit functions, we have example 1 here, 2 there, 3 there. All these are examples of implicit functions. And I've actually taken one example for you to try your hand on. So I'm going to do another one. Then from there, you try your hands on others for me. So another example is coming on board. So I have one example which is here, or another example which is here. It says, find dy dx in terms of x and y for the implicit functions here. And you agree with me that this is an implicit function. No specific variable has been made the subject, and therefore you have to go ahead and differentiate accordingly. Good. So I'm going to do number 1 and 2 with you. Then I'll give you some examples to try on. So number 1 is here. We have x squared plus y squared equal to 3xy. We are differentiating with respect to x, so we need to do it term by term. This is x squared. When you differentiate x squared, what do you obtain, please?
2x.
We have 2x. Good. Then when you differentiate y squared, what do you obtain?
2y.
Are you sure that it's 2y?
Yes, sir. Yes.
How many of you agree that it is just 2y?
2y.
dy dx.
It is
Dx,
2y dy dx. I always told you that you are differentiating respect to x. So any other variable that comes on board and you differentiate, it must always go with dy dx. So now we have the question written in terms of x and y. So when you are differentiating and you have the variable y there, whenever you differentiate, you should include dy dx. So we are having it as not just 2y, but it is 2y dy dx. Over here, it is 2x dx dx, but dx dx is giving you 1, so you need not to write it. Unlike this one, whereby it is 2y dy dx, the dy dx are two different statements, and therefore they can't cancel out to give you 1. So this is what is going to be left there. Equal to, at this point of the equation, we have two functions, and hence we need to apply the product rule here as such. So applying product rule, maintain the first function, which is actually is going to give us 3x, and differentiate the next function, which is y, which will give you what? When you differentiate y, what will you obtain?
dy dx.
You get dy dx. Then we continue with our product rule. So we maintain the second function, which will be 3y, and differentiate the first function, which is x. When you differentiate x, what will you obtain? 1. All right. Let me pause over here. Perhaps someone is not getting why I'm saying that there are two functions here and they are 3x and then y. And in another way, you can write it as 3y and x. That's why so you can also do it this way. If you are not getting whatever I just did here, this is how you can equally say this is 3 into brackets xy. So you can maintain the coefficient and then go as this. If these are two functions as x and y, the first function is x, the second function is y. So using product rule to differentiate, you maintain x and differentiate y, which will give you dy dx. Then continue with the product rule, maintain the y and differentiate x, which will give you 1. So at this point, I've been able to differentiate. But going further, then it means this 3, which is outside the bracket or the coefficient, can expand through. When it expands through, we are going to get 3x dy dx plus 3y. And it's the same thing that I've written here. My people, are you clear with me? Right?
Yes, sir.
So please, if you are not getting why I'm saying that the first function is 3x, the second function is y, you differentiate, this is what you obtain. Then when you are going further with the product rule, the second function will be 3y and then the first function will be x. This is the brain behind that. This is the brain behind that. Okay, so if that is clear, then I can erase this and then continue with my expression. So we've successfully actually differentiated, but we have not completely done it. What do you think at this point we need to do?
We'll make dy dx the subject.
Exactly. God bless you for getting that understanding. So we have to make dy dx the subject. Making dy dx the subject, we group all the dy dx to one side, so we can have it as 2y dy dx minus 3x dy dx equal to 3y and then minus 2x. Are you all with me?
Yes, sir.
Factorize out one of the dy dx. That will give us dy dx out into brackets 2y minus 3x all equal to 3y minus 2x. What must we do to make dy dx the subject at this point?
You divide by 2y minus 3x.
Wonderful. So we divide through by 2y minus 3x. So it will be left with dy dx equal to 3y minus 2x all on 2y minus 3x. And that is the solution to the question there. Let's go to the next example. So we have number 2, y multiplying s squared plus 1 all equal to 7. Good. That's an interesting question. There are so many ways of going ahead solving this question, but as I said, there is no need of making any variable the subject. Maintain every expression as they are and then use your rules accordingly. Now, looking at the left-hand side of the equation, we have y multiplying this function. So what rule do you think will be applied here?
Product rule.
Okay, so we are applying product rule and at the same time other rules. So please bear in mind, we are applying product rule at one point and at another side, you'll be applying the power rule. So take note of that. Okay, so let's differentiate. Product rule, so what must we do first? Maintain the first function. Our first function is y. So we maintain it, y. Then we multiply it to the derivative of the second function. The second function is s squared plus 1. So it is a two-term expression. So differentiating s squared plus 1, we are going to have, differentiating s squared alone is 2x. Are you with me?
Yes, sir.
You differentiate 1, you end up getting 0. So differentiating s squared plus 1, the answer is simply 2x. Plus, we go ahead with our product rule. So we maintain the second function. Our second function is s squared plus 1. That's our second function. And we differentiate the first function, which is y. When you differentiate y, what do you obtain?
Sir, please, can you start that one again? I didn't understand.
Now we have two parts of the equal to sign. We have the left hand side, we have the right hand side. On the left hand side, we have y multiplying s squared plus 1. So having such a function, I ask the question, what rule will be applied in differentiating the left hand side? And the answer was what?
Product rule.
Product
We are
rule.
using product rule. So using product rule, you have two parts of the function. First function, second function. Our first function here is y. The second function is s squared plus 1. So differentiating using product rule, maintain the first function, which is our y, and differentiate the second function. Our second function is s squared plus 1. So when you differentiate s squared plus 1, you differentiate it term by term. So what are you going to obtain when you differentiate s squared?
2x.
You get 2x. Because when you differentiate 1, you end up getting 0. So you need not to introduce the 0. Continue with your product rule. So plus, maintain the second function. Our second function is s squared plus 1. And multiply it to the derivative of the first function, which is y. So when you differentiate y, what will you obtain?
dy dx.
You obtain dy dx.
dy of y.
Then we go further. Differentiating 7, what will you obtain?
0.
You get 0. So at this point, you simplify and make dy dx the subject. So making dy dx the subject, actually what we're going to have here is 2xy plus x squared plus 1 all multiplying dy dx equal to 0. So making dy dx the subject, we maintain x squared plus 1 multiplying dy dx on the left hand side, and then transpose the 2xy. When you transpose 2xy, what will you obtain?
Negative 2xy.
Negative 2xy. Thank you. Then at this point, divide through by x squared plus 1, and therefore dy dx will be equal to negative 2xy all on x squared plus 1. And therefore, you have successfully differentiated the function. I would like you to differentiate this question for me with respect to x. Yes, what did you obtain as an answer, please?
So please, I had dy dx is equal to
So you had dy dx equal to
6 minus 2x plus 6
minus 2x plus 6
all over
all
2y
on
plus
2y plus
5.
5. Yes. Any other answer?
So please, I had the same thing.
The same thing. So I've gotten 2 people getting the same thing. Yes. Any other person?
That's the same answer I got.
So third person. Yes. Any other? Okay. Do I have anybody here who wasn't able to do it? So I've gotten 3 people getting the same solution. All right. Let's do it together. Then I'll tackle the next thing. Okay. So we've been given x squared plus y squared minus 6x plus 5y minus 2 equal to 0 to differentiate. And as I said, this is a perfect example of what we call an implicit function. So there's no need of making any variable the subject. Go ahead and differentiate with respect to x, and you apply the rules where necessary. When you differentiate x squared, you are going to obtain 2x plus differentiating y squared, you end up getting 2y dy dx minus differentiating 6x, you end up getting 6. When you differentiate 5y, remember it is 5y, so you end up getting 5 dy dx. 5 dy dx. Then you differentiate minus 2, you end up getting 0. You differentiate 0, you still have 0. Please, are we all clear with this?
Yes, sir.
Then we group all the dy dx. So we have 2y dy dx plus 5 dy dx equal to 6. We transpose the other terms, 6 minus 2x. Then at this point, we factorize dy dx out. Then you have 2y plus 5 equal to 6 minus 2x. Then we divide both sides by 2y plus 5. Therefore, it will be left with dy dx equal to 6 minus 2x all on 2y plus 5.